Good afternoon and welcome to Calix's presentation at NWR's Vantage Point conference. On the line today, we have Phil Hodgson, the company's CEO and Managing Director. Before I hand over to Phil to go through a brief presentation, I'll just remind you that we're trying to do this a little bit more interactive, so we encourage questions to be submitted through the Q&A panel at the bottom of the screen, which we'll endeavour to get through post Phil's short presentation. Phil, I'll hand it over to you now to get started. Thanks.
Excellent. Thanks, Simon, and thanks very much, everyone, for joining today. It's a fairly packed, tight format, as Simon has said, and I have got quite a few things to talk about. I mean, obviously, the slides have been made available on the ASX through the ASX platform. So as I run through, rest assured, you can go back and check on that ASX platform all the slides that I'll be talking to today. Just in terms of Calix itself, just a very quick, for those who aren't familiar with the company, coverage of, I guess, what the core technology of the company is. Basically, it's a new type of kiln or furnace. It's a new way to heat stuff up, as we say. And what we do is we separate how you heat from what you heat. And in a traditional kiln or furnace, you put both of those two things together, the fuel and the rocks, and light a match. It's been done much the same way for 5,000 to 7,000 years. In separating how you heat what you heat, we do that with a rather large steel tube. I've usually used a bit of toilet roll here to demonstrate that. The biggest one of these we've built is 1.8 metres in diameter and nearly 32 metres high. We heat this tube to 1,000 degrees centigrade, or maybe just a bit more. It doesn't matter how we heat that. It can be with traditional fossil fuels, it can be with biomass, it can be with waste, it can be with renewable electrons. And so the first advantage of the kiln is there. It's ambivalent, or as I should say, heat agnostic or energy agnostic in terms of how you heat this kiln. The second thing we do is what we heat, we put down the middle. It's got to be a small particle size, much the same as, say, flour, bread flour. Imagine holding a lump of flour in your hand and dropping it to the floor and just watching it float down. Well, that's all we're doing inside our tube. We're dropping what we want to heat down the tube, and as a fine powder, it just floats down through the tube. And the red hot walls of the tube radiate heat into those particles, and that's how we heat stuff up. Why do it this way is often we get the question we often get asked, and this is where my sort of rock comes into it. This is a lump of limestone. This is nearly half by weight CO2 trapped in the rock. And when the cement and lime industries heat this rock up, it releases the CO2, and that CO2 goes straight out into the atmosphere. It joins all the furnace gases and flue gases, and out it goes into the atmosphere. And cement and lime contribute 8% of global CO2 emissions, and more than half of those emissions are coming from this, so unavoidable. Let's go back to our kiln. Imagine ground limestone or the cement meal, which is a perfect particle size for our kiln already, just drop down the middle. We can heat externally, as I said before, heat renewably. And as the CO2 comes out of those little particles of limestone, it can't go anywhere except remain in the tube, and it makes its way out the top as a pretty pure stream. And so it represents just a different way to heat stuff up with a new type of kiln that can directly separate the CO2 that's coming from this. But there's a few other applications we're developing as well, and I'll cover a few of those today. Imagine this rock is a brown colour, iron ore, and imagine you've got our tube, the same core technology, and you have iron ore fines, millions of tonnes of which are produced a year and are suitable for pelletisation. And those iron ore fines are dropped down the tube, and inside the tube we have hydrogen. Hydrogen loves oxygen, and so what we're developing here is where the hydrogen, heated renewably through the outside of the tube, reacts with the oxygen in the iron ore to suck that oxygen off and make iron. So with iron and steel, another 8% of global CO2 emissions. And so we've got the one core technology that can address up to 16% of global CO2, cement and lime, and iron and steel. And so it's a very interesting potential and huge potential applications there. The last little bit of the tech I'll talk about today, imagine this is a different colour, sort of greeny and purpley, speckly, spodumene. Spodumene's a source of over half the world's lithium currently. And there's a project we're developing with Pilbara Minerals to use our technology to take ultrafine spodumene from their mining operation. And again, using our technology, renewably powered, crack open those little particles of spodumene and extracting that to make a lithium phosphate salt here in Australia. So one core technology, multiple potential applications. And in terms of the applications, all of the ones that we're developing are really powered, if you like, with some pretty strong tailwinds around ESG and industrial decarbonisation. Just a couple of stats here on policy and activity and spending that's needing to go into decarbonisation over the course of the next decades. And they're just staggering sums. And so industrial decarbonisation is a great space to be right now. If we have a look, just a few jurisdictions as well across Europe and the US and Australia, even in just the very recent announcements a couple of weekends ago, the US-Australia Climate, Critical Minerals and Clean Energy Transformation Compact, which is basically going to allow Australia to be seen as a domestic supplier in the US. Details still to emerge, but the Inflation Reduction Act is a huge US activity that is giving funding and support to decarbonisation. And the ability of Australia to be under that umbrella is going to open up enormous opportunities here and obviously in the US as well. And even in the recent budget in Australia, you can see here on the right of the slide, the Powering the Regions Fund is funded to some 400 million over 3 years to develop technologies that are going to solve decarbonisation in industries such as steel, cement and lime and alumina, all of those in our sites. So policies across Australia and the US developing rapidly. Of course, Europe, very important also. Our pilot project in cement and lime is in Europe. They've led the way to some extent with the European Emissions Trading Scheme and what's going to be called the Carbon Border Adjustment Mechanism, where a tariff is effectively placed upon CO2 on products. Again, just another tailwind for a technology like ours. I'll jump through to cement and lime first and have a quick chat about our project there. We've already built the largest CO2 separation facility for cement and lime outside of China. We built that in 2019 at a cement plant in Belgium with Heidelberg Materials. We're in a consortium with quite a few interesting players, not only cement and lime players, but chemical companies like Solvay, energy companies like Engie, and also in CO2 hub major players like Port of Rotterdam, developing one of the largest CO2 hubs in Europe. And so this particular project is very exciting for us. We're in the process now of Lilac 2, and I'll give an update at the end of this pack on where we're at with Lilac 2, but that's targeted to start commissioning in late 24. It's fourfold scale up of Lilac 1, so that will take it into being the largest separation technology on a cement plant once that's up and running. That'll be 4 of these tubes, 100,000 tonnes a year of CO2 separation. And on the far right of this slide, there are quite a few projects in our pipeline, and our pipeline that we updated at the half year had 71 projects all up. Quite a few projects in the pipeline targeting to have Lilac 3 units, which are suitable for full scale at their financial investment decision point as Lilac 2 comes in and proves the technology works at that sort of commercial module scale. And so lots happening on the cement and lime front. And just to give people an idea of the scale, I guess, of the issue facing the cement and lime industry and the scale of the opportunity, this picture is a lovely render that our team's put together of what a full-scale Lilac would look like, standing right next to its equivalent current technology, which is just a standard cement plant, preheater, pre-calciner tower. So you can see they're much the same scale, much the same size, but ours, of course, capable of separating the CO2 coming out of the limestone. We'll need to build 2 of these every week from now to 2050 to solve the CO2 problem for cement and lime. And so it's a massive, obviously, opportunity for us and a massive issue for the cement and lime industries. And all of those policy sort of outlines that I discussed before are pushing cement and lime industries to decarbonise, which puts us in a very nice position. Additional, though, to cement is lime. Lime is similar. It's obviously come from limestone, but we're developing a technology we announced with Heirloom on what's called direct air capture. And that's where lime produced from one of our kilns, which can separate the CO2. That takes the lime, it puts it through the Heirloom technology, where it's contacted with air to suck CO2 out of the air. When that CO2 is sucked out of the air back onto the lime, it forms limestone again. And so we then take that back into our kiln to separate that CO2. This one here is what's called just basically a calcium circuit or calcium carbonate circuit. And we're developing this with Heirloom. We announced this only, I think, in April. We also announced the type of license agreement that's going to cover this, which will be minimum royalty of $3 per tonne of CO2 separated with our technology. Heirloom is Bill Gates backs. They've got some pretty ambitious targets to be separating about 1 billion tonnes a year of CO2 by 2035. If they get a 10th or even 100th of the way there, that's a very significant opportunity for us with this type of license or royalty system in place. We've also achieved in November last year a similar license and royalty arrangement with Heidelberg Materials, and there's a couple of others on foot that again I'll talk about at the end of this slide. Just moving on to iron and steel now. I think everyone knows how important iron ore is in Australia. It's 44% of our export earnings, and there's a real opportunity if we can use the enormous renewable potential resources we have here in Australia to make a green iron and then export a green iron. And that'll be a 3 to 4 times uplift on the value of just simply iron ore exports. We're developing a technology called Z, same core technology, and against all the other technologies that are being developed for iron and steel, we've got some pretty important boxes we tick. One of the key ones is we minimise the use of hydrogen. Hydrogen is the most expensive part of green steel, and we're really targeting to minimise that hydrogen use again, because the hydrogen doesn't escape from our furnace. It's kept separated from how you heat, and we can recycle any unused hydrogen very easily in our technology. And so where we're heading with Zest is obviously to develop a solution for the iron ore industry here. And we're also looking at opportunities to have Zesty units on steel units overseas. Where are we at with that? We're trying to finalise what a 30,000 tonne per annum will look like by the end of this year. We've got some support from Arena to do that. We're right in the middle of doing some iron ore testing now, and I'll talk a bit about where we're at with that at the end of the pack as well. So it's a very exciting project to have a look at iron and steel. And similar to cement and lime, there's only ever half a dozen technologies that are ever going to decarbonise those industries, and we've got one technology that can address both. The last little thing I'll touch on is Pilbara Minerals. With Pilbara Minerals, we're developing the technology, as I said, to make a lithium phosphate salt. That particular project there is fast approaching its final investment decision point. And so with that one there, we'll be a 45% joint owner in a 3,000 tonne per annum lithium phosphate salt facility. I was just in Western Australia last week, actually, and toured the site there, had a good conversation with all the project team and with Dale about this particular project, and both parties are highly enthusiastic to progress. So with this one here, really keen to see this one hit its sort of FID point before the end of this financial year. And so just touching upon a few of the milestones that we've been targeting this year and where we're at with them. I've circled the ones here that are really my key focus and key priorities. I mean, they're all great to hit, of course, but those ones there are the ones that I really want to hit before the end of the financial year. I've talked about the Pilbara Minerals joint venture. The final investment decision, both parties are really targeting to get completed by the end of this financial year, so that we can move into the project really quickly and get it planned up and running, starting to get commissioned by late 24. So that one there is highly exciting and is a point of high focus for me. The other one I've circled there is converting 2 MOUs to full license agreements for Lilac. And again, in the public domain, of course, Cemex, Heirloom, we're working with to try and conclude those license agreements forward. But there's several others as well in our pipeline. And so getting at least 2 of those across the line in the short term is a high area of focus for me. Just across some of the other parts of the business, we've completed the basis design. You can see there under sustainable processing, we've completed the basis design of that iron demonstration facility and moving into more detailed front-end design now. And interestingly enough, the ore program, we haven't finished yet, but mainly because there's just been more and more ores to test. And so we've had to modify the unit at Bacchus Marsh to take in multiple different types of ores. Every major ore producer in Australia has now sent us ores to test on Zesty. So that's going to be a very exciting one to continue to move into Q1 next financial year and extend that testing program, given the interest that we've received to date. The other thing that we can sort of tick green, we've started to procure long lead items for the Lilac 2 project, and also the site works have commenced. So the demolition works that are required to make way for our tower are proceeding. And our permitting is the critical path. And so we're focused very strongly on getting the permitting completed as soon as possible. I think I've sort of hit the keynotes, Simon, so I'm happy to hand back, but happy to take some questions, obviously.
Perfect. Thanks, Phil. It's near on impossible to do an elevator pitch on Calix, given how many balls are in the air and how much you're achieving. But if we just start, you touched on Zesty and the testing ore program. Can you just talk to us, what's the key objective there, and post the results of that, what are the next steps, and potentially, again, third question, how will that be funded? Is it likely another sort of Lilac deal, into the future, or what's the sort of current thinking there?
Yeah, good questions. So the objectives of the test work are to achieve the same sort of results we achieved just on a couple of ores in the first round of testing across multiple different ores. As sort of people in the mining game know, ores ain't ores. So you want to test as widely and as deeply as possible on the different ores that are coming through. And so the objectives there are really to achieve the same metallisation extents that we did with the hertite, gimatite, sort of smaller samples that we'd done earlier, and extend that across multiple different iron ores from multiple different iron ore producers. What comes from there is that will feed into the design considerations in terms of the demonstration unit that we're targeting to complete by the end of this year. It'll also feed into the location. So we're interested in where do we locate this as well, and the ore, the different types of ores are going to help us in that decision, so that we may be proximate to a particular producer, for example. Other factors in that decision will be things like access to utilities such as hydrogen and electrons, power. So the program is really there to broaden the Zesty application demonstrably and help us with site selection. In terms of funding, we're looking at a project there that is probably at least as big as, say, a Lilac 1 and possibly halfway between a Lilac 1 and a Lilac 2. So the amount of capital required there is probably going to be of the order of, in a simple sort of demonstration unit, maybe 25 to 30 million. If we're having to build our own hydrogen sort of supply facilities, maybe a bit more. And so with that, obviously, that sort of funding is something that we're obviously talking to ARENA about, who've already funded the FEED study. But also, as you mentioned, when we look at where we're at with the iron and steel development, we're not that far behind, in fact, neck and necking with most of the other new technologies that are being developed. And some of the benchmark valuations for those new technologies are really quite interesting for us. And so if we were to do a Lilac type approach to getting equity in, specifically in to that iron and steel play there, that could be an option that is quite attractive to us and one that we're actively investigating.
And just a follow-on question, a couple of people have asked just around the anticipation of when those results will be released from the iron ore testing.
Yeah, we're targeting, so in Q1, so Q3 this financial year, or Q1 FY24, so end of that quarter. So let's say September, we should have the test program completed. As I say, it's had at least half a dozen new ores come into it over and above what we'd originally planned. So we're going to extend it and have a look across a broad, the full broad selection of ores that are available to us.
Perfect. You've talked to such a significant pipeline for Lilac. When do you expect to see, what this person said, the floodgates open there? And would that be potential news flow to come over the next 12 months, etc.?
The floodgates. I guess the floodgates in terms of naming actual companies and projects, that depends very much on the counterparty, because some are very cards close to the chest and others are happy to sort of talk about it in the public domain. Certainly, two license agreements that we're targeting in the near term are going to be very important for us. We're targeting several projects to be at FID at the same time Lilac 2 is running through its proof point in 2025. And so that means that several studies, more studies will need to move into feed stage in the very near future. And as we can announce those, depending upon our counterparty confidentiality regimes, we'll be doing so. Suffice to say, with 71 sort of projects in that pipeline, it's even if we can't announce who the counterparty is, we'll try and give people an idea with our typical pipeline slide as things move through there. People will be able to track how the flood is proceeding, let me put it that way. So we'll be constantly updating that pipeline for our stakeholders and shareholders.
Perfect. And just in terms of question around sort of strategy, more so on the medium to long term, you've got a number of different divisions that could be companies in their own right. Does the company have a view at some stage that it might make more sense to spin one or two of these out, once they are de-risked?
Yeah, look, I think what you've seen with the Lilac strategy is, in fact, spin out at let's call it TRL or Tech Readiness Level 6. We feel we're great at going from 0 to 6. And then from 6 onwards, the resources and the sector expertise required and the focus required is a logical point to have a look at what extra equity might be brought into those particular things. Let's call it a spin out, or let's call it an equity farm in, depending upon how much we own at the end of it. Lilac, we still own 93% of, so it's hardly a spin out per se. But absolutely, that is our strategy. As each of these come through and hit that sort of TRL level, or certainly a value inflection point for us, and a point at which we require that additional capital and expertise coming in, it makes sense to look at that particular spin out, that particular entity as a spin out. I mean, I've mentioned iron and steel. Absolutely, that's coming into the frame, whether it's sooner or whether it's TRL6 level, we're still to decide, obviously. And there'll be numerous other applications that will go through the same process. Again, I don't want to confuse everyone with all the different stuff we're looking at, but if you have a look at some of the stuff under sustainable processing in other applications that we're looking at, I've mentioned alumina, there's various others as well. All of those are ripe for the same sort of, let's say, strategy. And so that allows Calix as a head company to really concentrate on that TRL 1 to 6 that we've been really successful at so far.
Perfect. And in terms of the global license agreement that was signed with Heidelberg Materials back in October 2022, how's that progressing? And is there any sort of key milestones ahead of that?
Yeah, so that's on foot. Obviously, the discussions with Heidelberg have moved on from just the license to projects, etc., beyond just Lilac 2. And obviously, we'll be disclosing those as and when we can. So the license is on foot. It's permanent. It's global. And so there's no work effectively that is going back on that license. What we're concentrating on now with Heidelberg is working out what the next projects are.
And we've had a couple of questions just on the Pilbara joint venture, and you mentioned during the presentation, but I'm assuming that's still on track by the end of June this year.
Yep, that's right. So I've left that blue. Obviously, a lot of work goes into a final financial investment decision. This is not a light decision for Pilbara or us. We targeted to complete that decision this year, and we remain very focused on trying to get that over the line this year.
Perfect. And just last question, Phil. Obviously, we've proven that we can capture CO2, but without the use of sequestration, it can be quite an issue. What's Calix doing on that, or what's the industry doing on that to provide that solution as well?
Yeah, and look, I didn't have time in today's presentation to jump into that in too much detail, but there's a project that we announced again just back in April with Arena backing that we'll be working with Adbri to produce a CO2 stream for a green methanol project. So this is taking CO2, combining it with hydrogen and producing green methanol. Now, green methanol is a drop-in fuel for existing transportation options like road and marine. It can be converted once you convert your marine engines properly, you can run 100% green methanol in a marine application. And green methanol is also an excellent precursor for synthetic aviation fuel. Now, I'm not advocating that every drop of CO2 that ever gets produced by a cement plant can go down this route. We know that sequestration is going to have to be an option, which is, while we're partnering with hubs in Europe and while we're looking at the US and those cement plants proximate to CO2 infrastructure. But what's really encouraging about the project that we're developing there with Vast Solar in South Australia is the ability to show how industrial units can come together to produce a green methanol and utilize that CO2 in that way. And that CO2 utilized in that way, by the way, is fully accredited in the EU with respect to being an option to deal with the CO2. It's not classed as an emission per se.
A perfect answer, Phil. Thanks so much for the presentation. If anyone had any follow-up questions or wanted to chat further, please just reach out. But Phil, thanks very much for presenting, and thanks all for attending.
Again, thanks very much, Simon, and thanks all for your attention.
Cheers. Thank you.